Welcome to Unit 3, Lesson 2, Multiplication with Non-Unit Fractions. In our last lesson, we learned how to multiply with unit fractions. Those are fractions with a numerator of 1. I have an example already written here, and I would like you to pause the video now and solve this problem, then come back and see how well you did. Prairie Town is 15 miles away. If you have driven 1/3 of this distance, how many miles have you gone? Quickly, I first want to circle my numbers, make sure that these are numbers that I'm going to be using. And if I have any action words, we want to circle or underline those in this case. The word of is an action word, as we learned in the last lesson. Of means multiply. And what I'm trying to find out here is how many miles have I gone. But I've only gone 1/3 of the 15 miles that I need to go to get to Prairie Town. Prairie Town's 15 miles away, and I've only gone 1/3 of the way. We also learned in the last lesson that when you're multiplying whole numbers times fractions, that you're going to get an answer that's less than the whole number. You can never forget this as long as you remember a simple problem, such as if there are 4 bananas on the table and you get half of them, how many bananas will you have? What is half of 4? We know the answer is 2. You can do that in your head. And 2 is less than the total amount of 4 that were there. So 1/2 of 4, turn that 4 into an improper fraction because we never multiply with whole numbers. Multiply straight across, you get 4 on top, 2 on the bottom. You have now an improper fraction that when you divide, 4 divided by 2 equals 2. So if you use a simple problem like this to remind yourself of what type of an answer you should get when you're multiplying fractions and whole numbers, then you can always check very quickly for reasonableness. We're always wanting to check our answer and make sure it seems reasonable. So when you're not sure of what kind of answer you should get, just go back to the banana problem, a very simple banana problem. There are 4 bananas and you have half of them. How many do you have? Now let's get back to our problem. So Prairie Town is 15 miles away, but I am only driving 1/3 of the distance. I'm not driving the entire distance. I have to break that distance up into 3 equal parts because I only drove 1/3 of it. You can look at that as a number line going from 0 to 15. If you were to break that into 3 equal pieces, this would be a third, this would be a third, and this would be a third. Altogether, that would be 3/3, or the entire distance of 15. We could use this number line now to figure out exactly what 1/3 of 15 is. We only need to figure out how far this distance is. And since I'm breaking 15 into 3 equal parts, then each part must be worth 5. So there must be 1, 2, 3, 4, 5 there. Another 5 in the middle, which would give me 10 at this point, and then 15 at the very end. Each section cut into 5 pieces. Of course, you could use this number line to solve simpler problems like this, but they do get more complicated, and you are going to want to be able to multiply instead of drawing number lines. So let's solve this using multiplication of whole numbers and fractions. So we'll set this problem up. I drove 1/3 of 15 miles. That's 1/3 of 15 miles. I know from the previous lesson again that of means multiply, so I will rewrite that to 1/3 times 15. I can't multiply by a whole number, so I'm going to turn that 15 into an improper fraction, and turning any whole number into an improper fraction is just as simple as putting a 1 underneath it, because 15 divided by 1 equals 15. And now I'm going to multiply straight across my numerators and my denominators. This is all you have to do for multiplying fractions. 1 times 15 is 15. 3 times 1 is 3. I now have an improper fraction that can be fixed and should be fixed. By looking at this fraction as a division problem, what I have here is 15 divided by 3. And 15 divided by 3 is 5. confirmed that 5 is our answer. Now turn to page 71 of your workbook. Make sure you're looking at the same page, 3-2. Read the question in your head as I read it out loud to you. Silver City is 24 miles away. Gus has driven 1/4 of the distance. Emma has driven 3/4 of the distance. Question number 1 says, how many miles has Gus driven? We have two number lines over here, identical, both going from 0 to 24, representing the 24 miles away that they must drive. They've even drawn a car for you to show you that somebody is driving from point 0 to 24 miles. Gus has driven only 1/4 of the way. They showed that as well on the number line by dividing the number line into fourths. Each of these parts is 1/4. He is now driven 1/4, which you can see very clearly from the number line is exactly 6 miles. Now, how many miles has Emma driven? 18 is correct. Question number 3 is the tricky one. How many times as far as Gus has Emma driven? How many times further has she driven? You can see on the number line that she has driven further. You can see on the number line that if she had only driven this far, that would be the equal amount. So they would be equal. If she drove 12 miles, that would be twice as far as 6. And 18 miles then is 3 times. 3 times as far. Now in question number 4, we're going to create a number line to solve this problem. If 1/5 of a distance is 3 kilometers, then how far is 4/5? So let's draw a number line and break it into how many equal parts? How many equal parts are they asking us to break these into? Both these fractions are into fifths. So 1, 2, 3, 4, 5 parts that are equal, which requires 4 vertical lines. If 1/5 of that, and each of these is 1/5, is equal to 3 kilometers, that first line then would be equal to 3. The next fifth would be equal to 3 more, and 3 plus 3 is 6. Can plug in our 0 here. And each fifth subsequent to that would be 3 more. That would be 9, 12, and the last fifth would be a total of 15. It says that 1/5 of the distance is 3, so then how far is 4/5? So if we started driving and we went to 1/5, 2/5, 3/5, 4/5, we can see that 4/5 is going to be 12. Using the same method, pause the video and try to do number 5 on your own. Here on number 5, it says that if 1/8 of a container weighs 2 pounds, how many pounds is 3/8 of a container? So if you use the same method that I used above, you could use a number line, and we would want to break that number line into eighths. We'd be starting with 0, 1, 2, 3, 4, 5, 6, 7, and our last one, 8. We now have 8 equal places. Each of these is representing 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8. 8/8 would be your last one, which would make the entire number line whole. It said that 1/8 of a container is 2 pounds, so from this distance, from 0/8 to 1/8 is 2 pounds. Therefore, 3/8 would be 2 pounds plus 2 pounds plus 2 pounds, because this is your 3/8 here. And just total up the total number of pounds you have now, and that would be a total of 6 pounds. Again, now pause the video and do number 6 on your own. For number 6, it says if 1/7 of a book is 4 pages, how many pages then would be in 2/7 of a book? Using the number line way of solving the problem, we simply need to create a number line that's broken into 7 equal pieces. This would be 0, 1, 2, 3, 4, 5, 6, and I'm going to need to make it a little longer, 7. Each line's representing 1/7. There's 2/7, 3/7. I don't need to go to 3/7 or any further, in fact, because I only need to go to 2/7. Each seventh is equal to 4 books, or 4 pages. So here's 4 pages for the first 7th. And my second 7th would be another 4 pages, which gives you a total of 8 pages. I'm just going to help you set up the problems for number 7 and 8, but you're going to do these on your own. It says Shady Grove is 40 miles away. Middletown is 1/5 of the way there, and Parkview is 2/5 of the way there. So you can imagine that we're going to be setting up a number line. You should be drawing that number line right now. That number line will go from 0 to 40. That's how far away the Shady Grove is. And we will need to break this number line up into a number of equal parts. How many equal parts will we be breaking it into? Hopefully you said 5, because our denominator on both of these fractions is a 5, which means it takes 5 parts to make the whole thing. So there's 1, 2, 3, and 4 lines to represent 5 equal parts. And that's as far as I'm going to go in helping you with this problem. I'd like you to complete 7 through 12 at the end of this video on your own. Turn your page now to page 72, please. On this page, we're going to be doing some multiplication without using number lines, but I'd still like you to visualize the number line. First, I want to talk about some of the vocabulary that's over here. As you can see, the two numbers that you are multiplying together are called factors, and the answer to any multiplication problem, as you already know, is called the product. Now we're going to take a look at our problems over here, number 13, where we have a set of problems for 13. They're asking us to find 1/3 of 18 as well as 2/3 of 18, but without using a number line and drawing one. So instead, what I'd like you to do is just close your eyes for a minute and listen to what I say. In your mind right now, I'd like you to draw a number line. That number line is going to go from 0 to 18. Now I'd like you to cut that number line into 3 equal parts. Once you have that done, I'd like you to envision just 1/3 of that number line, because we're being asked to take 1/3 of 18, or 1/3 of that entire number line. Now predict if your answer would be less than 18, equal to 18, or greater than 18. If you said less than, you'd be correct, because you're only taking a small part of the entire number line, only 1/3 of it. Now envision taking 2/3 of the 18. And again, predict, would your answer be less than 18, equal to, or greater than 18? If you predicted less than, you would be correct, because you're not taking the entire number line, so it's not equal to it. You're not taking more than the number line has to offer, so it's not greater. But instead, you're only taking 2/3 of it, 2 out of the 3 parts that you broke it up into. So the answer should be less than 18. Now let's figure out exactly how much each of those thirds is going to be worth. If the number line total is 18 and you're breaking it into 3 equal parts, then each part, if they have to be the same amount, must equal 6, because 6 3 times is 18. So 1/3 of 18 then is only going to be one part of it, which is just 6. And 2/3 of 18 would be 2 parts of it, which would be 12. 6 plus 6. I'd like you to use the same strategy to complete numbers 14, 15, and 16 in your head. Pause the video and come back when you have them complete. Number 17 has a list of expressions. All of them are fairly similar to each other, but only one of them doesn't really say the same thing that the others do. So I'd like you to pause the video and see if you can figure out which one is not like the others. As we take a look at these, I'm looking at the first one right here. 2/3 of 21, which means 2/3 times 21. But I read it as of, I naturally do that. And you can see the problem next to it actually has the word of, so these two are very much alike. And so now we have two that are alike, and we know that we're looking for expressions that mean the same thing, or will yield the same answer as 2/3 times 21. Let's take a look at this problem over here in parentheses where we have 1/3 of 21 plus 1/3 of 21. That actually sounds like it's the same thing, and it is the same thing. 2/3 of 21 is really 1/3 plus 1/3. 1/3 plus 1/3 equals 2/3. So if we broke it out into separate unit fractions, we would end up with 1/3 times 21 plus 1/3 times 21, which is basically the same as 2/3 times 21. Just below that problem, we have 1/3 of 21, or 1/3 times 21, and then multiply that times 2, which is essentially the same as well. The reason why, again, is because we're taking the product of 1/3 and 21 and just doubling it. And that's what they're doing over here as well. They're taking 1/3 and doubling it, turning it into 2/3, and then multiplying it by 21. Whether or not you double it first and multiply by 21, or use unit fractions and then double it, will still yield you the same answer. I'm going to move over one problem to this one. This is 21/3 plus 21/3. And this problem is essentially the same problem as well. In fact, it's really a lot like this problem here with the addition sign here. Really, if you solve this problem, you would have to do the parentheses first. And if you did that, you would end up with, if I solve this one first, I would end up with 1/3 times 21. 21 would become 21 over 1. To turn that 21 into an improper fraction, you would get 21/3. So the first parentheses would be 21/3. The second parentheses would be the exact same thing because we have the exact same problem. So we have 21/3 there too. And as you can see, that if we solved each of these parentheses, we would end up with 21/3 plus 21/3. So that is this problem. And that leaves this problem, which must be our answer. And it is, because 2/3 plus 21, of course, is not the same as 2/3 times 21. I think utilizing all the information you've learned in the last 2 days, you should be able to do number 18 on your own. Number 19 and 20 we will do together right now, and the rest of this page you will complete afterwards on your own. Number 19 says, suppose the bus station is 2 stories tall. Remember we talked about variables. Variables are these letters over here. Now, if the bus station is 2 stories tall, then we could put the 2 there because that represents the number of stories. But we need to figure out what n equals in this expression for the bus station so that we can apply the value of n to the sports shop and the bank to answer questions 19 and 20. And the way I'm going to do that is to use what we've been using, number lines. And I'm going to create a number line, and I don't know how long the number line really is. I don't know what the last number on the number line is going to be, but I do know how many times I'm going to break up my number line. Let's look at our expression for the number of stories the bus station has. The expression is 1/6 of some number. 1/6 of some number. And that, whatever that number is, 1/6 of it has to equal 2 because they told us the answer is 2 stories tall. So the bus station is 2 stories tall, and that is 1/6 of some number. So what I can do then is break my number line into equal parts. How many equal parts will I want to break it into? Well, my denominator says break it into 6 equal parts. So that's what I'm going to do. 1, 2, 3, 4, 5, 6 equal parts now. And I know also, because they told me that the bus station is 2 stories tall, so 1/6 of whatever this number is here, n, equals 2. And this is a 6th here, so that's 2. and every sixth is 2. So we can continue to plug in our 2 for each sixth. And now we can tell what n is going to equal because we can just total them. This first number is 2, then 4, then 6, then 8, then 10, then 12. So n equals 12. You might want to rewind this and watch that happen again. Now that I know that n equals 12, I can start plugging it into the formulas that I have. On number 19, it wants me to say how many stories the sports shop has, and the sports shop has 5/6 of n, and I know that n is 12. So I can take 5/6 of 12. Well, I can use the same number line that I have here, and I can go, this is 1/6, this line, this is 2/6, 3/6, 4/6, 5/6. And I'm looking for 5/6 of 12. So here's my 5/6 of 12, which just happens to land on 10. On number 20, it says, how many stories does the bank have? The bank has n stories. Well, we've already found that. N equals 12. There's no expression there. The bank just has however many stories n equals. And since we've already found that, was quite easy to do then. On the next problem you're going to have to solve on your own, you're going to suppose that the bank is 5 stories. The bank is 5 stories. So you can plug in the number 5 here. I'll do that part for you. And this is actually a lot simpler because we now know what n equals, because the bank equals n, and we now know that n equals 5 stories. So you'll just be using 5 to plug in to your equations when you find out how tall the hotel is. On 22 through 24, you'll be doing the same exact method, but you'll be supposing the hotel is 36 stories tall. So this is going to be 36, and you'll have to figure out what n is here. And if you just would draw an equal sign here, you might see an easier way to do this than using a number line. We're not using fractions here. It's 6 times n, not a fraction times n. So if you think of n as a box that needs to be filled in, what number would go in that box to make that equation true? That is what n will equal. Complete the rest of these on your own.